Let's explore a few ways to improve hologram stability and fidelity. When you're ready, press Next on the navigation panel. Let's compare bicycle cogs to illustrate why it's important to achieve 60 frames per second. Achieving 60 frames per second is important for more than just a good visual experience. It's also critical to make sure objects appear locked in space, and also to ensure the experience does not cause discomfort for some people. We've loaded a detailed CAD design for a bicycle cog that hasn't been optimized for HoloLens. Look around and notice how the experience jitters. This is what happens when you don't achieve 60 frames per second. Now select the optimized cog design and look around to see the improvement in performance. Feel free to try both options and compare. When you're ready, press Next on the navigation. Let's look at the assembly task list to illustrate the use of late-stage reprojection, or LSR. Feel free to drag the task checklist to observe the effect. Try moving your head side to side while looking at the list. See how this is causing jitter. The device's late-stage reprojection system uses the depth buffer to stabilize holograms. Without a backplate on the task list, the gaps between the text cause reprojection to adjust continuously between near and far, causing the jitter. Notice how the jitter is reduced when we add a backplate behind the text. Make sure that all of the materials in your app write to the depth buffer as well. The depth LSR mode will yield the best hologram stability for most apps. If your app has models with sharp changes in depth, autoplanar mode may lead to better hologram stability. You can also quickly toggle between the modes in the device portal. Try it out now. When you're ready, press Next on the navigation panel. Your next task is adding one of the decals to the frame of the bicycle design. Go ahead and select the decal, then drag it to the bicycle frame to apply it. See how the frame is interfering with the decal? This is called Z-fighting. Z-fighting typically happens when two surfaces on different objects resolve to the same Z-depth value. It can be particularly noticeable with motion, where the distance between viewer and holograms are changing. To fix this, we'll move the decal forward just a bit, to eliminate ambiguous Z values that are used to determine which object is meant to be in front. Try both options for the decal to see the difference in Z-fighting. You may have to move closer to, or further from the bicycle until you see the interference pattern on the decal. Or you can take a closer look by dragging the bicycle towards you if you wish. When you're ready, press Next on the navigation panel. Did you notice that the text on the task checklist panel sometimes shimmers or looks jagged and is hard to read? Also notice the shimmer on the wheel spokes. This is called aliasing. Unity's Text Mesh Pro and MRTK shaders substantially reduces text aliasing. For 3D assets, avoid using thin and high contrast geometry if possible. Compare the difference for yourself. In this module, you've experienced how model complexity can impact frame rate, the importance of using LSR and depth buffers to stabilize objects at different distances, and situations that can cause Z-fighting and aliasing. Press the Back to Home button to return to the main menu.